Hello everyone, Assalamu alaikum. Let's continue to the next learning objective, which is finding the equations of tangent and normals to a circle. Let's have a look at what is equation of tangent. So in this case, 4.1, we have a circle, isn't it? So from this circle, we have a tangent line that touches the circle there. It always touching the circle because the tangent means tangent is the line that just touches the curve. So in this case, the curve or the function is our circle function here. Our circle, equation of circle, we have it from the question. And then we know that the circle can consist of a tangent line as well. If we are going to find the equation of tangent, we know that the tangent line will touching the circle. So there are a few methods to find the equation of tangent from this circle, okay? So the method one is finding the gradient first. Okay, finding the gradient is just m equal to y2 minus y1 over with x2 minus x1 over here, which I believe we have seen this before during your SPM level. Okay, where there are 2 points here, point P and point C, for example, and then you minus y2 minus y1. Okay, whatever you want to y2 minus y1 or y1 minus y2, it will give you the same thing eventually anyway. Okay, so you will use this formula exactly, y minus sub y, and then below it x minus x. Okay, just make sure you have two points over there. Okay, and then you can, after you got the gradient, you can sub in the gradient m into the equation of tangent. So please bear in mind that this is equation of tangent. All right. So I should label here, actually, here is T. MT. T means tangent, the gradient of the tangent. Because first thing first, step one is always finding the gradient of tangent. That is always the first step. If the question is requesting for the equation of normal, you will need to find the gradient of the normal from here. This is another formula where you need to memorize, which I know you already memorized it, and you sub in the gradient of the tangent from the step one, and then the step two here, you find your gradient of normal. Okay, it's okay. I'll show you later from this, from few examples that I'm already prepared here. Just want to show you a bit of method here. Okay, method two here is just by using formula. So the formula here is quite long, okay? And if you can look closely, it is almost similar to the equation of the circle, the GE of circle, isn't it? Almost the same, but not the same. So we have here a bit different there. It's okay. So now let me introduce you to the next method, which is method 3. We are going to differentiate the equation of the circle to find what? To find the gradient of the tangent. As we know, the meaning of the gradient of the tangent is just dy dx. And so dy dx is just our MT, which is the gradient. All right. So I am going to use this method 3 to teach you guys how to find my tangent. Okay. So let's have a read at this question. Find the equation of tangent. See, highlight this word. Find the equation of tangent to a circle x squared minus y squared, x squared plus y squared equals to 13 at the point of 2, 3. So here is my equation of circles given there from the question. Sentiasa akan diberi pada kita the equation of circles. You don't have to worry. They will give us. So now our job is, by using the method 3, we are going to differentiate every term here. We are going to differentiate x squared, differentiate y squared, and then differentiate 13 with respect to x. Everything is differentiate with respect to x. Okay, so now let me show you how do we do that. We will get 2x plus 2y, but this 2y must have dy dx with it. Okay, so I use the orange color so that you remember whenever we differentiate y with respect to x, it means we must have dy dx as well at the back of the 2y. All right, and then we continue differentiate a constant, gonna always give us 0. So this is actually a knowledge from 9.4, sorry, 9.4 implicit differentiation. Okay, which I bet you know this already. If you forgot, please look at my semester 1 videos. All right, chapter 9, 9.4 implicit differentiation. So now let's continue to find our dy dx. So our dy dx is just equal to negative 2x, sorry, negative 2x. Negative 2x divided by 2y. And so we simplify it, we will get negative x over y. So that is our gradient actually. So here I wrote down my mt. My mt is equals to my gradient, which is dy dx. Okay, so please know that dy dx is a gradient. Okay, so gradient is equals to mt. We know this already. And so in this question, my gradient of tangent is negative x over y. So I am going to use this to sub into the equation of tangent. But before I sub into the equation of tangent over here, I would like, it's not about how I would like, it's about given. It's about given from the question at the point of t, coordinate t here, which is 2, 3, we can sub in the value inside of this tangent, inside of this gradient of the tangent. So we will get negative 2 over 3. So what I did here is just I sub in the 2 and the 3 inside of this gradient. Okay, and so I got negative 2 over 3, and then I can now sub in my gradient mt into the equation of tangent that you already being very familiar with. And so don't forget to sub in the y1 and the x1 from this point here, 2 and 3 there. Okay, you sub in everything, the point t and as well as the gradient there, and you solved it, you will get this equation. Okay, so that is our answer, the equation of tangent. You can leave your answer like this, y equals to negative 2 over 3 plus 13 over 3, or you can leave your answer like this, 2x plus 3y minus 13 equal to 0. So this is just sort of like a proper line in equation, the equation of tangent line, you know. So this is like, you know, there is no pecahan. Jadi dia sama dia rata je. Equation looks very nice and perfect there. But it's okay. I think both equations is accepted anyway. Okay. Let's go on to the next example. Find the tangent and then the normal line. So they want two equation, which is one is the tangent line, another one is normal line. So they are two different lines there. Okay. So look at this. Look at this equation of circles. How do I know it so quickly that this is equation of circle? Because I'm used to it. The x squared plus y squared plus 2gx plus 2fy plus c equal to 0. So please make sure you are very familiar with how to write the equation of circle, and you know that this is literally the general equation. So I hope you know that, how to look at them. Okay, so this is the equation of circle given to us. So what we need to do is to find the gradient first. So I'm using the method 3 sahaja. So we are going to differentiate every term here with respect to x. Again, the same thing anyway. Okay, so I'm using the method 3. You can use whatever method you prefer. I want to use this instead. Okay, so I'll show you how do I differentiate this. It is just 2x plus 2y, dy dx, don't forget, dy dx, and then plus, and then minus with 6, minus with 10, dy dx, and then minus with 0, and then equal it to 0. Sebab yang ni differentiate negative 82 with respect to x. It is 0 anyway. So it's just these things. And then I am going to group the dy dx. So I factorize dy dx. And then I'll get a group of, what is this? 2y minus 10. And then the rest of it, I bring it to the right-hand side. Gonna give me 6 minus 2x then. So I make dy dx as a subject. I'll got this one. 6 minus 2x over 2y minus 10. That is my gradient. Okay, so I label it as mt. Okay, please bear in mind that dy dx is a gradient. I repeat, dy dx is the gradient. Okay, and so this is mt. Okay, the grade t means the tangent lah. The gradient of the tangent. That is always the first step. Whenever you are trying to differentiate with respect to x, it always gives you tangent first, not normal. Okay, it's always tangent dulu. And so at the point of here, -1 and -5, you just sub in the value of x and the value of y. I mean the coordinate of x and the coordinate of y in there. So I put it in, I'll get -2 over 5. Okay, after I sub in the point, the coordinate of x and y here, x1, y1. So I got -2 over 5. I sub it into the equation of tangent. Don't forget to sub in the point -1 and -5, because that point is very important. You know, this point is important. It always be given to you all. Don't worry. Okay, you solve it and you will get this thing. Y equals to -2 over 5x minus 27 over 5. Or you can write it down as 2x plus 5y plus 27 equal to 0. So that's it. This is your equation of tangent. So equation of tangent is different to the equation of normal. Why is it different? Because this is called as tangent, you know. This is tangent because tangent means that the line of the tangent will always touching the circle here. That is the meaning of tangent line. You know it already. How about normal? The normal is just perpendicular. The normal line is just perpendicular to the tangent line. So the gradient will be different then. Okay, the gradient is different. The gradient of the normal is not the same anymore. We call it mn. The gradient of the normal is different than the gradient of the tangent, right? You know this already. So I won't explain this so much. So after you got this mt, which is step 1, yeah? After you got this -2 over 5, you can find your mn, which is the gradient of the normal, by using this formula, which you know this already, okay? And so you find the mn equals to 5 over 2. All right? You just simply use this formula, you rearrange it, and you will get mn equals to 5 over 2 instead. And so you are prepared to find the equation of normal, which is the same equation anyway, y minus y1 equals to m times x minus x1. So you just sub in the gradient of the normal there, 5 over 2, and then sub in the point, the same point. Okay, the same point. Why is it the same point? Because it is just at this particular tangent line touching the circle. That's why we are just going to pick this point. Okay, x1, y1. Okay, so that's why I put here x1, y1. This is just the simply x1, y1. And so sub in the x1, y1. Okay, and you will get another equation, which we'll call this the equation of normal, okay, which is y equals to 5 over 2x minus 5 over 2. Or you can write it down as this one, 5x minus 2y minus 5 equal to 0. This is the equation of normal, okay? So is it the same as the equation of tangent above? Have a look at this equation of tangent. So the equation of tangent is different, right? It's different than this equation of normal, not the same at all. Because why? Because they have the different gradient. Okay, now it's your job to do it yourself, try it yourself. We have a given equation of circle there and a point there, and try to find the equation of normal, like the requested here. It says find the equation of normal from this circle equations and the point there. You do it. Let's see whether you got this right or not. I got this. If you got it right, please comment there in the video. Say that, yeah, I got it, madam. Thank you. And that's all from me.